co-host. Thank you.
Okay, everyone. So the plan for today is talk about unit tests in JavaScript. Basically, I plan to do some introduction and then giving some hands-on. And feel free to ask questions in the process, or we will have time for later as well. But I will try to be more in the details of what is the test and some best practices, but we will try to, in the end, to show some examples as well. Okay, so, okay. Oh gosh. What did I do? Okay. So this is the agenda for today. So it will be why we should do tests, what is actually unit tests and unit tests in JavaScript. So I mean, you can see the agenda we will talk through in the process. Yeah. Okay. So I think here is just more an overview of what are the types of testing that we have it. And starting for the basic, this is the traditional pyramid of testing, which the base is about the unit test or component test. Then we have integration tests, system tests, and there are more, and acceptance testing in the top. But I think for now, let's focus in what is the basic and what is the part of makes stronger for everyone. And this is part of the unit test that we are going to talk today. I think it's very important to know that it's really very important to do a unit test and to do tests and why we should do tests. So this helps us to understand or to quick identify bugs. It simplifies the code maintainability because you can see logic that you can create multiple times and can be reduced. There is also refactoring, that in case you want to refactor, you know that your test is covered, and then your code is covered. And if you change something, you will still save that you can proceed. With integration tests, it also gives you more confidence because whenever you do any test, you have some automation that is taking care of running. Because when you create a test and you don't run, or you depending of your memory or a person to run it, it's kind of a danger. So with continuous integration, this is allows us to test and be more assured that everything is working as expected. And then this is okay, this is application. And also when we need to make sure that features in the past is working and new features we have also will be working. So in the case there's a regression prevention is important. Yeah, and what is exactly unit test? Unit test is a test that you can try to find the small piece in the code to test it. This can be a function, this can be a method, this can be a logic, a minimal amount of logic that you can do in your code. So considering this as a component of an application and keep isolated from the rest of your code. That's why it's unit test, that you only test the least or the small piece of your code to make sure that that's working. And the purpose of the test is validate each of these unit if it's working in the end what is planned. Like if you have a sum, then you know, like if you sum 4 and 5, then you have 9. Then this is your small unit. Or if you have a controller which has many functions, and you should test each one of them. And then this is basically what is unit test. So just to summarize, is the smallest testable part of your application. In that case, again, function, method, or a class. And also needs to be public in a way that you can access. That's also one of the requirements. And And okay, I think I found this image, which is very interesting when you understand how is the life cycle of the unit test. So you make a change in your code, then you execute your unit test, then you find some bugs, then you have your code review, then you push your change to the repository, and then in the repository you could have a system, a CI that runs the test and also makes sure, because different environment, different behaviors. So that's kind of the whole cycle. And then if you see some error in the CI, then you make another change, or the feature is not working when you go to the second test, or as a long or as a big feature, then you come back to make a change, make a unit test, and so on. The order of the test and create a test and make a change can be different, because if you add a BDD approach, which is first create the test and then later do the code, then this order can change. But depending on your preference, and depending on sometimes of the company, like a culture, let's say like this, or the preference, internal preference. Okay, now going to talk more specific to JavaScript. Like when we talk about unit tests, this fits to any type of language. But thinking about JavaScript specific, there are many different frameworks that are kind of libraries to support to run tests with JavaScript. So I listed here like the top ones, and I personally work with Mocha and with Jasmine in the past, but I know Jest is like one of the favorites tool in the moment, mostly because of React and other tools. So this is just gives you a lot of tools, mocks, and supports in order for you to create the task easily, and then you don't have to create everything on your own, which is still possible. Now, here, just starting, I will focus specific on Jest, which is the one that it's kind of the top one used at the moment. If you want to use Jest, what you should do is just use npm library and install, which is a node, and then you create a function, and then here you add the task for this function. Then there is the need of create the package JSON, which contains how you are going to run the library and also the dependencies for your tests. And in the end, you run npm test, and that's it. This will be the output of your test, saying that you run one test. It's very straightforward or simple for creating the unit test with Jest. Jest also gives you a lot of possibilities. So, for example, one of their top deals is like it's a very fast framework that you can run many tests, and it's very quick. Here is kind of one example when they run around 332 tests, and then in the end it was 4 seconds. And the visibility when something fails is very nice, because you can understand exactly which line it fails, and the color, what was expected, what was the feedback that you got it. In that case, it was expected to be with Jest, but it got with a lag. So that's kind of the idea. Now thinking about a unit test, it's very important that you follow some structure and makes easier for you to understand what is being tested and what's the behavior that you are trying to make, and also to make easier for others to follow your code, your thoughts of the testing. And considering this as a unit test, one of the best approach in the anatomy of the test is to do this 3A pattern, which is arrange, act, and assert. When basically, if you look at the second view, it's like set up your test, the execution of your test, and verification of your test. So let's say in this example here, you have a class which is called calculator, and then your act is to add some numbers. And then this is the result const that is returned here. And as the last part is assert equals the result of 15. That means 5 plus 10 is 15. And this is the assert logic. Follow this pattern. Try to make this pattern, and know that will be very easier to maintain, and is also very good structure to follow. And like this is just a correlation with this setup, execute, and verificate. The other part that's very important here is to think about mocking and stubbing. So mocking is when, because it's a unit test, you don't want to test things working together as a container. For example, if you are testing, if you are creating a class that stores something in the database, so you have two parts here. You have your class, your code, and you have the connection to the database part of the code, which is another testing as well. In that case, it's very important for you to understand what is the small unit that you have, and you don't want to test integrated, or you don't want to test in containers, so you shouldn't be testing the database together to your class as a unit. If you want to test that, this should be called container tests. It's part of the unit test kind of behavior, but thinking more as a small piece of your code. First, test your code specific independent. You create a unit test for your controller. You create a unit test for your database logic. Don't try to test them together. And in order to test that, you just need to mock sometimes, because you are depending of other connections to other behaviors to do your logic, to do your test. So in that example, for example, here, there is the mocking behavior when you want to test that you request some API, and then your API returns something, and you want this something to be returned to you. So this is like, I'm not testing if the API is correct. I'm not testing how the API is implemented, if it's done with which logic. What is the contract that you have? I'm getting a REST API that I'm expecting, let's say in that case, 200, which is a success test. And I'm testing that given a 200 test and a body as ID 1, you are going to mock the response. And in that case, your unit test for this will be returned the same one. And that's when you have to think about this mocking, and when you rely on the mocking to make that work for you. The same goes to the study. And for example, you are doing, when we have in JavaScript, you could have, for example, adding logs to your application. So you can have a warning, an error, you can have a debug log. And as part of your unit test, you want to say, if I insert some data, it should return true, like or the same data, and in the log should return an info saying everything's done correctly. And in your test, you want to make sure that this log was created, and this is part of a step that you want to watch. Somehow I want to spy on extra resource. In that case is the logging, and then you use this stubbing to check this data, and then you can basically spy in the information and see, okay, in the log before I had nothing, now I had a success. Or if I had an error, actually I didn't got a success message. So as part of your small unit in your test, I'm testing, I inserted correct, and there is a message that is part of your assertion. The message is success, for example. In this, you will need these mocking and stubbing kind of things, because it's dependencies that you need from outside world. That's not exactly your small code. Like if you sum a data, that's your code. But if you sum a data and you log, and you add a metric, or you, let's say, throw an exception that do something else, This is the outside world, so it's not as part of your unit, and then you should just considering these options to know how to make sure this is working. Okay, then of course it's not just happiness, everything is good, unit test is simple as it is. No, there are a lot of challenges. As you know, it's not all the engineers are very concerned or taking care a lot of unit tests. Why? Why is that? And one of the challenges is really about dependencies and mocking that I was just telling. When you do have external libraries, external tools, external things that you rely, it's hard. Sometimes it's hard to make the connection and then make sure this is working. Mocking sometimes can be very challenging if you are not very familiar with the language, or at some point becomes just mocking, and you are kind of not really doing the task that you need. So this is kind of a challenge to know a balance. Another challenge is about asynchronous code. For example, when you are doing a REST API, like I'm calling an API, and this API takes a synchronous call. I'm waiting for this answer, and this can take 1 millisecond, can take 2 seconds. Every environment is actually different. So how I can make a code that can work in this situation, consider any possible problems that can happen. So it's kind of difficult to do that. The other one that I think it's more the most complicated one is about maintaining tests. So you create your code, and if you are the one creating code, changing the code and creating the tests, it's all fine. But we are talking about teams when there are a lot of people building code and a lot of people creating tests. And if you create a code that is not testable, and then you have to maintain that test, the test change, then you have to go there and fix, and this cycle and back and forth, as I explained again, it's kind of a challenge to make the right call, and also to concern like how amount of test or what is important for me to test, because this has to be maintainable. If you don't maintain, it's got out of date, it's not testing anything, and it's just bringing more noise than helpful. So when you are testing your code, there is the concept of code coverage, which is usually most of the company has around 60, 70, 95% of code coverage. But code coverage per se doesn't bring any value. If you have a method that you are testing and then somehow your code just calling the method and then execute all simple branch, and this can return as 100% of code coverage. But that doesn't mean that you tested everything that you needed. So this is very a point that is challenged, because the balance between coverage and what is actually critical to be tested and what is really important to be tested, it's difficult to have that, and it's more feeling from the engineer, from the person that's coding the information. Now talking about legacy code. When you start a company, and if you think about 10 years ago, testing, it was not really a point of concern. Quality was not a point of concern. So most of the codes on legacy, you don't have really enough tests. Sometimes you don't have any tests. And you basically have to migrate, you have to do some maintenance, change something. You are not sure how to do that. And it's a very difficult situation that you have to change, and you are not sure that you know all the details. So here it's important to, what would be the suggestion or solution for that is, instead of try to cover everything that is already there, if you do a change, whatever you added, you cover it. And then after some time, things are going to get better, and then you will improve code coverage with the time. So like, as a tip, like lift the code always better than you found it. So if you have something that you can improve, and there's something that you can test it as part of your scope, try to do that, because that will be a good thing. Another a difficult situation is when you're trying to test in private methods. You can do that. There are some tools that allows you to add a notation that you can see that method as part of a public, but not all of the tools offer that. So I would say that you better keep what is public and try to do all the branches in order to get into the private, but it's not easy. And I really don't recommend you to expose private methods just for the sake of testing, because this is also more danger than actually giving the test. So the scope of public and private is very important, and don't try to expose just because you needed to test, but you can still test it as part of the public methods as long the code makes sense, and then we are going to get there. Flake test is really a challenge, and a lot of people get annoyed and even give up on tests because of that. So you run locally, everything's fine, no problem. But when you move to the CI, then it starts not working as expected because the system is different. So a task that depending, like if you combine, for example, synchronous code, this is one of the reasons that you have some flaky tests, because there is concurrency between tests. If you run tests in parallel, one test may be affect other, and you don't know, you didn't realize, because when you are running locally, it's different behavior for you. But I think there is also a say that it's better not having tests than having flaky tests, because in that case, the flaky test gives you some confidence, or sometimes it's just creating so many noise to you that it's breaking, but then you run again, it's working. So it's something to consider, and that's also something that I did in the past. If something is flaky, if I don't have the time to fix at the moment, disable the task, create a ticket, and take a look later. If you do have the time, of course, it's always better to fix that, but we know that in real life, we not have the time for that, as always. And then that also comes to the second, the one challenge, which is about timing and resource constraints. So in some companies, or there is some deadline that you have to finish things quicker, that you need to finish as that. And then what is the first thing that people give up is the test time, because it takes time to write tests, right? And it's very difficult to find the balance that I need to write code, but if you don't write tests, it's your feature is not done, it's not complete, and we shouldn't be giving up of the tests when we don't have time to finish some feature. As kind of a tip in that case, I would try to reduce the scope if it's possible, but not reduce the tasks. Or, I mean, you can reduce the amount of coverage, but still keep having the critical information being tested, or what is the main crucial point for your system to be tested, rather than just giving up of the unit tests. The last one is also a big deal. It's about culture, is about feeling, is about communication, is a team education. Not all the teams, not all the engineers having the same culture of quality. Not everyone has the same feeling of why test is important, and that we should be doing tests. So this is very difficult to put that on the top of the team. This is crucial, this is important, and to have everyone in the same page. Because if you are the one doing the test and the others are not doing, you are not going to have a good quality, because you have 5 people coding and only one doing tests. So finding this balance and try to create, for example, knowledge sessions, sharing material, blog posts about why test is important, why we should not give up on tests. It's a challenge that we are going to face at some point in time. Even ourselves are going to, like, I've been in a time that, okay, I have no time to do tests, I cannot do the tests. But if you put that in mind, that you feel that actually test is part of your development process, and you understand how important is that, you are never going to give up on that. And that's kind of a together thing. You cannot deliver a code if there is no test. And that's something you can try to align with your team, to your managers, and try to build the culture of that in case there is not. Sharing presentations like these and share books that talk about that is also another tip that you can do for the teams. Now, I think this is with the challenge also comes to the best practice that every technology, every code has, and for tests is not a difference. So when you are thinking about a unit test, and this is very important to make that independent. So you run a test that's specific, only that test is not affected by other things, is not in communication with other other library. That's the small part of that. Everything outside should be mocked that you can handle, or you just don't need to touch that, or every piece is done the test independently. When you are testing, it's very important to have a proper name. It's not just testing one. That doesn't bring any value. If the test breaks and then you see test one, okay, what is this test? What is the reason for this test? Why is it important? Why I did that test? Because test is documentation to your code. In case it breaks, you know, okay, we do have a hack solution in order to attend clients. And if that's the case, if the client is 1, 2, 3, then it should return something. And this is an edge case. Then that's also, if you write that in the test, this is testing client 1, 2, 3, edge case, and expected that. So put a name that makes sense. Make clear that's the test, the descriptions that you're writing is not for you, it's for others. And it's for documentation that can be shared later. As a practice that I also mentioned, this AAA pattern, like arrange, act, and assert. Don't put imagine that you are testing a sum and a division, and you shouldn't test both of them together, but create a test that just tests the sum. And then you do, if sum, for example, you want to test the sum with 0 with negative values, then you create a test with that. And if you want to test with positive values, you create another test. Don't put everything in one block of tests, because that's if fails could affect because something else, and then you don't know it. It's usually better to create specific tests, just a really small, and create a duplication, like a test sum with positive, test sum with negative, divide by 0, throws an exception, divide by negative number, you know. So do, like, if you want to test division, try all the tests, but create specific tests for each one of them, because then otherwise you will have an assert that is asserting for everything, all the topics, all the data, and that's very hard to maintain. Isolated tests, that's is another thing. Like when you do have a controller that does many things, I guess this is also about a code. When you are creating a module in the controller, you should not create a controller that does everything. You should create specific. So I have a controller for user, I have a controller for a client, I have a controller for, I don't know, authentication. And then when you are testing, it's the same thing. You do a test that is only for that matter, for the user, and then it's for the user type. Let's say if you have a different type of user, you can create 2 types of a test. And here, of course, the external dependencies, you need to mock it. This is kind of very important. The edge case is what I mentioned, like you should test not only one test, because if you do a sum, just 5 plus 1, it's 10. This is normal. Okay, but what if you test, let's say, if there is an object and you can add anything, then you can test with not a number, sum not a number. What is the expectation to happen that, because if you're just thinking about coverage, if you create one test of the set, it's covered, it's 100%. But did you actually test everything that you need there? Did you try to send not a number, undefined number, a null number? Do you know, is it possible to do all of that? So those are edge cases that needs to be tested, and they are even more important than actually coverage. They are important for you to know what your system supports. Here is about test public interface. So if you have an API and your API is the REST and you have a get, a put, list, you test that. It's very everything of your methods that you have. Any public method must be tested as part of like a contract is very important. And here also it's a hint that you could use the before and after to avoid duplication. So imagine that you every time when you want to start your application, not application, in your test, you have to set up some object to the test. So, and then reset the state. So before every test, you can say reset the state. And after I want, if the data you are using database, then you want to clean up the database. So use that to avoid duplication. So you don't have to, everything that is duplicated in your tests, you can reduce and put that in the before and after if you're using multiple tests. This makes more readable and it's easier for you to follow steps by step. And here is about organization of the tasks. So usually I would say that you have to follow the partner of the project. If you don't have a partner that you are building something, it's usually good for you to try to follow what are the guidelines of the language, what are the guidelines of the company, what is the structure. But brief structure. So if you have, let's say, payment, and then you have a user, a package, create folder. Don't put everything in the same place because it's very hard to find where it is. And try to follow the same structure as you have it for the source code. In some companies, there is also common to create tests and the source code together in the same folder. That's really depends. So it's more for your getting the feeling, but try to make organization or put them in some package and break down. If you have more than 5 and 6 files in the same package, it's just kind of an indication that maybe you could break down in the more levels that it's easier for you to follow. Okay, if I'm trying to check utils, is utils for database, is utils for parsing or regex or for date format. So create specific for that and make this organization. When you are running the test, it's also important to run fast, because if the test takes around 35 minutes to run, and every time you have to run the test, imagine how many times you do a change and you have to run the change. So it's kind of important for you to make sure, and there are also some tools that you can analyze which test is taking longer, what can you improve it. But keep in mind that the velocity of the testing is important because this is your time waiting for that to finish. This is this time in waiting for the deployment. Maintaining consistent of the test data. This is, for example, instead of you every test set up a user and you have to create a user. I want to create a user 1 with a name Adriana, with a last name Zenck, and with I don't know, language English. Then in another test, you are going to create Adriana again and do all of that. So instead of creating the same setup of data for your test, you can create factories. So if you are having a factor for user, you can create a user and then you can put as parameter the name, ID, and something. And instead of you initialize the user every time, you can just use the factory, or could be the examples of your testing, and you can use there instead of duplicating all of that all the way to your tests. Okay, regularly reviews and refactor tests. Every time it's important to, if you are changing a class, take a look, make sure that everything in the test is still valid. That makes sense. That sometimes we remove a method and then we just forgot about the test. And tests are there and not testing anything. Of course, they usually would break if you remove the code. But it's better to keep in mind that maybe have a look in the test if it's still valid or if you have to add something else when you are changing. The automating test is what I mentioned about using a CI to make that running, and then you don't have to run only yourself. Or you can, when you do a commit, you also can do a hook in your Git to run the test before you commit, or you can have it on CI every time that you push something for your pull request, run the test, and you get a notification. So you don't need to remember of that. Sometimes you just create a test and you push the code, but then having automation to run this test for you makes your life easier. So we should try that. And these coverage tools, as I mentioned, is really nice because then you can see what is covered in your tests, what are the lines that is missing, the branches, and if it's kind of how much of code coverage you have in your project, which is kind of a big deal to know. But keep in mind that only these metrics is not enough. And going to the documentation for the test, just giving a description for your test, like say testing method sum, it's good, but you can still add a documentation like a Java doc, or like add some details. This test is doing this, and that. Or you can add some comments. I would be just careful a little bit with inline comments, like don't need to document everything. If it's clear to understand, don't need to comment. But if it's an API, it is something that is more critical, it's a bit confused, you can add documentation because this will help others in case the test break. And then you help others to figure out. And yes, educate the team. This is a team effort. It's not only about yourself. Try to keep with the team, align what is the strategy you want to do for testing. If you are using, for example, the partner of give and when then, or you don't want to use any partner, do you want to start every test methods with a test? So try to talk and make agreements with the team. What are the rules or the guidelines, the best practice you want to follow? This is kind of a team agreement because you are working in a team. You shouldn't be doing your way, another person another way. This should be kind of a company, a team decision. So try to come together with the team, learn, participating of conference events talking about that and how can we improve, what is missing, what you can do better as a team. Okay, before I go into the hands-on, I first I go to the just talking a little bit of the integration test, and then I will share something. But is there any question that I can answer now, or is it fine if I continue? Okay, I guess that's good. I don't see anything on the channel, on the chat. Okay, so as we already mentioned about continuous integration, I'm going to just give one of examples. What is actually continuous integration is you have like a software that is running continuously the test for yourself. And there are many different tools for that. Like a very standard one is Jenkins that it has for a long time. It's just maybe for me is more familiar because it's Java. But nowadays we have a very simple one, which is GitHub Actions. That's for free. If you are using repository on GitHub, you can use directly GitHub Actions for that. And every time you do a change or every time you push some code to master, then you can run the test. That's depending of what are the configurations, what you want to do. Of course, GitHub Actions is not only for CI. but it's also for CD, like continuous deployment. So imagine that you run, the test is working, and then you can deploy. If your test is not working, you cannot merge your pull requests. If the test is not working, you cannot deploy. So this is kind of a integration. So keep in mind the integration word here and the continuous integrated continuous deployment. That's kind of the deal together here. And GitHub offers you all of that for free, and it's very easy, and it's very common to companies to use. But not all the companies are using GitHub, the public one or the private one, even though, but they offer different kind of tools for that. For example, on Google Cloud, there is a cloud build, which does essentially the same thing. That's run the build of your test. Like when you just do build or you do test, it does that for you and give an output. With GitHub Actions, then basically you can do all of that. Let's build, test, and deploy the code. And what you need to do is basically to create a YAML file in the folder which is called .github. You create a workflow, and then you create a YAML file that, in that case, I call pull requests because it was a workflow for whenever there is a pull request. And what is the steps that is doing? So the first step here, let's say, is just download a Node.js, install the dependencies of your package, which is the line 18. And then in the line 21 is what exactly you need. Run npm tests. So if you are using Jest, it's just about the JavaScript, just run npm tests, and then it's going to run. And here in the screenshot below, you see in your pull request that whenever you push something to your branch, and you already have a pull request, you are going to see in progress the check. And then later, for example, if you go here in the check, you will see all the steps that's been doing the GitHub action. So it was creating the job, check out the repository, install dependencies, run the test, then complete the job, and with a success because you see that's green. And later you will see in your pull request this checkbox which says run with success, no problem, and done. That's it, what you have to do. And it's very simple for JavaScript. It's very simple for you. If you want to create your pet project, you can just do that, and you don't even have to run locally, but you know in your pipeline that's doing that. But just keep in mind you have to do that for the pull request. But if you want to do, for example, when you merge something to master, let's say you can do that when you do a pull request, but after you press the button merge, you want to run it again. So basically you can create the same thing as you have it here, but instead of have on pull request, you do another action. And this is kind of offers many options. Can be on commit, can be on pull, on push to master, on push to specific branch. That's kind of give you a freedom. And if you have an integration test, end-to-end test, you can also add here, like if you before you deploy, you could do that, run the integration test. If only it runs the integration test, then you are safe. Or you can keep a job that is running every 20 minutes on the GitHub Actions to do an integration test, for example. That's also a possibility. Well, okay, now I'm going to show you some code. Yes. So here, when we are talking about, let me go first with the steps. Okay, when the first step when we do it, install the Jest, then basically what is going to show to you is this. You have Jest, the latest version, and then you will have the test. And then basically with this information here, when you do it, it's also creating here, just for your information, this is the mentoring website. So if you're not familiar, but here there is also creating this Jest config, So, and then let's say it's done by that. You don't need any extra information. And when you do, now here, when you do npm test, you are going to see all the tests that you have it, what is passed, and what's the time that it's taking to run. In that case, basically, when you go here in this example, what I created was just the sum, the same as we have in the screenshot. And when you go to the test, you import that, and then you do the sum add 1 plus 2, then should be 3. And that's it. From the package, that's what we have it. But then, so this is just the basic setup. You create one test, and here, for example, we have this in this assets code, which is in the example. And then here I create test assets JS, and then we have example test.js. What is important is you have to create .test.js in order to know there is a test. Now, when you go, like coming back to the script itself, you can see the code coverage. If you do that, I just get, let me keep that. Okay. Oops. Okay, so here I add other plugins to do something or other things, but I will just go show first the code. Going back to the, it's going to create this package .lock.json. I do recommend you to keep that in the code and you push, because this is, when you push this version, basically, you know which version is the one running of your npm, and then that's what you are sure that if I run in my machine and if Eleonora runs on her machine, they should be the same. If it's not, then could have a conflict, could be different. But if you are starting from scratch, of course you don't have it, but then you can just update. When you do npm install or npm update, usually it's going to update that, and basically it's on what we are seeing here. And when you added this, it can be like a 0, but sometimes you can just say bigger than 1.5, and then whenever you update, you're going to get the latest version. And here in the jest, then I'm going to, what I added here, it's just for your, this configuration is to see the code coverage. And when I do that, basically when I'm running the test, you will see, yeah, now I did something bad, but anyway, here you are going to see here that what is the coverage of that. And in the setup, I said that like any code inside of assets.js with a JS extension or a JSX, and ignoring node modules, and it should be a text summary in this. When you see that, basically we can see that it's creating a coverage folder. And then, okay, here, let me get, and it's going to give you all the JavaScript or all the code that you have it, and how many code coverage you have it. In that case, here says that we cover 100% branch, but it didn't cover anything just because I called the method, and you can see everything here that's red, that's not covered. But as you are going to improve that, you are going to see other code coverage. Unfortunately, I will not have all the time to do that with you, but I'm just giving you some hints of what I did so far. I will push all the chains, and we can, if we are interested, we can continue in the next session to actually go just by hands-on in doing the test together and seeing the output, the improvement, the code coverage. So here I added also to ignore the nodule models and the site, because this is an output of the GitHub pages. And this part is about when I want to import a test in my JS file, for example, I want to load this. And then when I go here into my test, I have to do this required, which is, in this case, you can see that I put it, this is kind of the standard of JS. And then I want to import the example file. And here, when you go in the example, that's the one. And based on this config, I'm saying everything from the root here from assets.js, anything that will be replaced by the source. But you can kind of play around and change that a little bit. And that's how I could import the sum, and then we could run the test. That was the reason for the configuration. Okay, another thing that I quoted, which is here, it's kind of, it doesn't have the example. Let me get it here. So we could have, for the jest, there is also those methods, which is the before all that you can do before do any test, call this method. And instead of adding, you could just basically, if you have one test here, you could just do everything here, right? So you could just add all your requirements here, but trying to follow the approach that we say, like do, like create. The example that we have, it will be, for example, we have const, which is value 1, which will be 2. Then we have const value 2, which will be 5. And then you could, of course, do that result, which is a const. And this result will be the sum of value 1 and value 2. And the expect result to be 2 plus 5 to be 7. And that's kind of following the approach, like you give the definition, what you want to do, then you is the action that you are testing, and then is the assert and the expectation that you are doing. And let's say you could, at the same time, if you just do, of course, if you don't use const and we could just do that. Or let me do more, the most common thing to do. You could just basically do that, oops. This, right? This would work, right? But that's what I was saying about these. We are going to test, let's say 0 plus -1. Then you are going to test a string with 0, and this is expected. Let's say I don't remember the syntax, but it's like throws an exception. And that's really what we should avoid. So ideally what we do is one assert, one test, one definition. And then if you want to give more assertions that is different tests, then you should create another test. And by that, it will be just create another test like this, and that's just to then here, and in that case will be okay, so like this is kind of another approach. Given not a number value should throws an exception, and then this is part of the name and the documentation. Then your test will be and then here you do the assertion of, okay, if I sum value 1 with the value 2, it should throw an exception. But then I have a specific test for that, and it's not going to have all of that. Because if you have these two tests, this could fail and this could not fail. And then this, if this fail, you don't run all the exception. You would stop right here. And in that case, you are not sure. And that's one of the reasons why you shouldn't create more than one assert. One good example to do multiple assertion will be, just go back to the previous state here. Okay. So if you have another test that is returning get user, then you pass ID 1, and you could have, let's say that you have a user that is a JSON, which will be ID, and 1, let's say name, and in that case, you could, of course, you could test the user to be expected user, or you could just do 2 assertion, which would be 1 user ID and the user dot name. In that case, it's fine because you are not creating a different test. You are still the test or the like the get user here, which will be a result user. This is the same method. You are only called once. You are not changing the parameters here. Is always user 1, and you are getting this user, and that's it. And then you can have many expectations as you need, because they all belong to the same tests. They belong to the same exceptions that you are doing. Now that, so this is one other example. What else? Okay, I think I will stop at this time. I will have more examples, but I would like to share more in the mentoring page, which is, for example, we do have those method or those controller, and then we would be able to create tests for that. And the same goes for mentors and for search. So take kind of a real test, a real code that we have now in our open source, and then create tests for that together. And I think if it would be nice for us, we can do that in the next session. That will be just hands-on. Now that we all have kind of the best practices, the introduction, the gist, and I will raise this pull request. So you all, I will share with you all the pull requests and the examples, the presentation. And then we can try to do that together, or you can also try on your own and see what we can do it. Then on next week, we can do another round just for the hands-on of the tests. Questions? I guess. Now, Nora could